Okay, good afternoon, everybody. Let's continue with our discussion from last time about normal distribution and standard normal distribution and how to go between two distributions, one being just arbitrary normal distribution and another being the standard normal distribution. So let's talk about some examples. So normal distribution, that's what we were talking about, normal distribution. Which has n mu sigma square, mean mu and variance sigma square. All right, and then that's any arbitrary normal distribution, and then you have standard normal distribution, which I call SND, standard normal distribution, that has mean of 0 and variance or standard deviation of 1. Remember that standard deviation is 1 or variance is 1 and mean is 0. That's the standard normal distribution. And normal distribution, regular normal distribution, is something with the mu and variance sigma square. Now we can go back and forth between these two distributions. How? So let's say this is a normal distribution with mean mu, standard deviation sigma, and I'm considering another normal distribution which has a mean of 0 and standard deviation of 1. I can go back and forth between these two by using the z formula. Z is equal to x minus x bar divided by s, or z is equal to x minus mu over sigma, depending on what we are dealing with. We can go back and forth between these two. And also remember, a normal distribution is uniquely identified by its mean and variance, okay? Normal distribution is uniquely identified by its mean and variance. So if you have one normal distribution with the mean mu1, variance sigma 1 square, another normal distribution, mean mu2, and variance sigma 2 square, they are two distinct and unique normal distributions. Now, the way I explained this thing to you guys last time I did it, if I gave you two distinct points, there is only one line, straight line, that can go through this, okay? There is only one straight line that can go through this, or another way of saying the same thing, there is only a unique straight line between two distinct points. In exactly the same way, if you have these two parameters, mean and the variance for a normal distribution, that uniquely identifies a normal distribution. If you have a mean and variance, that uniquely identifies a normal distribution, the way two distinct points identifies a unique straight line. Now, having said that, any question, anybody, before I get going?
None.
No questions? All right. In that case, what I'm gonna do is this. I'm gonna go ahead and sort of like do a warm-up example of what I did last time, so that you kind of remember what we were talking about. So we had this assumption that we are talking about some income that is normally distributed. We exclude any extreme data points. So we have something that is mean mu of 35K, okay, and standard deviation of 7K, okay. Now, normal distribution with mean mu is 35K or standard deviation 7K, or you could assume this to be X bar as well, average, sample average, and this could be your S, sample standard deviation. Once again, try to remember, S is the sample standard deviation, okay? And sigma is the population standard deviation. Then mu is the sample, population mean, and X bar is the sample mean. All right, mu is the population mean and X bar is the sample mean. Is this clear, everybody? All right.
Yes.
Also, while I'm on the topic, P is the population proportion, and P hat is the sample proportion. Please make sure that you are clear on these definitions, because if you are not clear, then when you're doing problems, you're gonna kind of mix it up. All right, now you do remember that for normal distribution, we have a formula. So it is difficult to find probability using that unless you have some sort of computational device. But we have something called standard normal distribution that has a mean of 0 and standard deviation of 1. We can go back and forth between these two using these formulas, right? So what we do to find probability associated with one normal distribution, we convert it into standard normal distribution. So this is just good old normal distribution. And from that, we go to standard normal distribution using the z-scores formula. And then we look it up in a table, okay, for standard normal distribution table. We look it up in the standard normal distribution table, and the probabilities are the same for both cases, meaning probability that we get here is the same as the probability that we get here, okay? I'll do plenty of examples using this, okay? But let's go back and look at some of the things, z-scores, how to find your z values. And before that, please make sure that I sent you an email with a formula, z-scores table. Please, everybody check your email and make sure to have it handy because you will need that. Now, let's find some z value. So I have this point, let's call it 38.5K. And I want to translate or map rather this point to the corresponding point on the standard normal distribution. Remember, standard normal distribution has a mean of 0 and standard deviation of 1. I want to convert it into standard normal distribution. So this middle point, the mean corresponds to the middle point here, 0. So 35K maps to 0. Now 38.5K, it is to the right of 35K. So that means it's going to be to the right of 0 here. So the z value is going to be on the right side of 0. So this point maps to this point. Now, how do I find out what is the exact value of z that corresponds to 38,500? It's easy. Z is equal to x minus x bar divided by sample standard deviation. So x is the point in question, 38,500, minus x bar is 35,000, all of it we divided by 7,000. If you do the math, you're gonna get 3,500 divided by 7,000. So 3,500 goes into 7,000 2 times. So that is gonna give you 1/2. So z is equal to 1/2, which is, by the way, 0.50. So the z value that corresponds to 38,500 is 0.50. Now, if I want to find the probability, so let's find something. Find the probability that somebody, a randomly selected person, makes less than 38,500. Let's say we want to find that probability. Remember, in the continuous case, probability is measured by area under the density curve. In the continuous random variable case, probability is measured by the area under the density curve. So what area are we talking about? Less than 38,500. So this is my point 38,000. So let's draw a vertical line. So we are talking about less than, meaning all the area to the left of that point. That's what we are talking about. Everything to the left. Now, this normal distribution is not in the standard form. You can potentially just find the value with the calculator, but I use the table, okay? It's easier. So we go from this to that, okay? That means standard normal distribution using the Z formula, right? Which we did use already. X bar divided by S. Now, probability of X less than 38,500 is the same as Z. Look, this value maps to a Z value of 0.5. So this is the same as probability of Z less than 0.5. Now remember, 0.5 is right here, and this is the area I'm talking about. Now, everything to the left. Okay. Now, these two shaded regions in terms of area, it's exactly the same. Okay. They're exactly the same in terms of area or percentage of area under the curve. Okay. So you can go ahead and see what it is. Now, how do I find this? If I can find this, okay, if I can find this, I can find that, because proportionately these two areas are the same compared to the total. Remember, area under the entire curve is always 1. Area under the entire density curve or density function is always 1, because you can think of it this way. Probability of all the items in the sample space added together is 1. Or probability of the sample space is 1. Remember, we talked about it before. Probability of the sample space is 1. Okay. So you add up all the probabilities in the sample space, that should add up to 1. In exactly the same way, but the continuous case, all the probabilities under this curve, this density curve or bell-shaped curve or Gaussian curve here, all the area adds up to 1. So the proportionate area is the same. So now let's go ahead and find this value. This is where you'll need to use the table, everybody. Okay. You'll need to use the table. So please go to your email, everyone, and open the table and go to page number 6 on the table. Page number 6 on the table. Everyone, please take a moment and go there. So if you look at page number 6 on the table, you'll see is the positive z-scores, by the way. And then under z column, under this column, you will see 0.0, 0.1, 0.2, all the way, it keeps going down to up to 3.5. So, okay, we are interested in 0.5. So now let's say we want to find out 0.23. Okay, so let's say we are looking for 0.23. What you will do, you go down the z column and look for 0.2, which is just this. So right here, 0.2. Then after you do 0.2, then you go along that row and go up to column 0.03 because 0.2 plus 0.03 is 0.23. So the value that you have right there in the intersection of this row and column is the value for the probability for z value. Okay, so that means if we want to find the 0.23, so that's going to be the probability that z is less than 0.23. And remember, it always gives you area to the left. So everybody go ahead and find the probability for 0.5. What do you get for 0.5? So please unmute yourself and you can tell me. I see George put it on the chat. That is right. Anybody else got anything? Okay. If you look at it, you'll see 0.5 and 0.00 column, which is right here, and the value there is 0.6915, 0.6915, which is 69.15%. So that means this area to the left of this point, so this vertical line, look, this vertical line, all the area to the left is gonna be 0.6915. That means probably that z is less than 0.5. Probably, see, look, z value is 0.5. Probability that z is less than 0.5 is 0.6915 or 69.15%. But z maps to, look here, to this point, which is 38,500. So the probability that someone makes less than 38,500 is actually 0.6915. They're the exact same. Okay, they are exactly the same. Is this clear, everybody? Or at least making some sense?
Yeah, it's clear.
Yep, pretty clear.
Okay, good. Now I'm going to give you an example. I want you to spend a little bit of time, okay? And I'll be doing the problem for you too. I want you to find this probability, exact same numbers. Probability of x less than, let's make it $49,000. Probability that somebody makes less than 49,000. And if you are a bit more creative, you can also type probability that x is less than 56,000. Probability that somebody makes less than 56,000, or probability that a randomly selected, when I say somebody, it means a randomly selected person, okay? It means a randomly selected person makes less than 56,000 or 49,000. Go ahead and work on both. Again, assume mu is 35,000, or yeah, mu is 35,000 and sigma is 7,000. And draw the diagram, shade the appropriate region, and then look it up in the table, z-scores table, and that would help you. Please make sure to be able to understand these problems. If you're not clear, please let me know. Don't hesitate, okay? Because I want you to learn these materials because this is something very important and you're going to be using it a lot for the rest of the semester. In every lesson, pretty much you'll be using it. Normal distribution and standard normal distribution, their properties and everything. So please work on this seriously. If you get stuck, let me know. So I'll give you maybe 3 minutes to try it, okay? And then I'll ask you. Any question before I let you work on the problem? Anybody?
No.
All right, thanks. Okay, guys, how is it going? Anybody has any question, or were you able to solve it?
Yeah, was able to solve it.
Okay, good. What did you get for answer?
First one was 97.72%, and the second one was 99.87.
Okay, both of them sounds good. Okay, if you got it so far, that's great. I am hoping that most of the people got it. If you got it, fine. If you didn't, that's when I need to help you, and you need to speak up, please. So anybody who didn't quite get it, would you volunteer how far you went, and would you share your process, what you tried and whatnot? Anybody? Everybody got it? There is not a single person who didn't get it?
This one
Is
seems
it that?
pretty simple.
Yes.
Yeah, compared to the last lesson.
Okay. Okay. All right. I'm very sure there are some people who didn't get it. You are just not speaking up, right? So, yes.
Danny got 97.72,
Mm-hmm.
but I got 0.9772.
Yeah, it's the same thing. He said it in percentage and you are saying it in decimal. Exact same thing.
Oh, I see. Okay.
Okay. So my first one is 35K and 49 would be somewhere here, right? 49K, and your standard deviation is 7K. So I want to find out the probability that someone makes less than 49,000. So everything to the left, first of all, less means left, more means right, okay? So I'm looking for this. Now, to find this area, so probability of X less than 49,000. To find this, I need to go to standard normal distribution, which is a mean of 0 and standard deviation of 1. So this point must map to a point somewhere here. Okay, that's my Z. And we need to find that Z value. How do I find it? Z is equal to X minus mu over sigma. I can go back and forth between these two. And I'm just gonna find it right here. Z is equal to X minus mu over sigma. X is the point in question, which is 49,000. 49,000 minus mu is 35,000, right? 35,000 divided by 7,000. So Z is equal to 49 minus 35 is 14,000. 7,000. 14,000 divided by 7,000 is 2. So Z is equal to 2. So this point is 2. So probability of X less than 49,000, that translates into the Z, this area, into Z, this. All right. Probability of Z less than 2. Now you look into the table, positive Z-scores table, and for 2 is the same as 2.00, right? So 2.00 gives you 0.9772, which is the same as 97.72%. That's how you'll do the first one. And the second one is exactly the same. I'm not gonna draw that whole thing again. I'm just gonna go ahead and write it out. 56,000. 56,000. If you convert it into z-score, you're gonna see that z is 3, probability of z less than 3, which is the same as, if you look at the table, 3 gives you 0.9987, 0.9987. That is to say 99.87% chance. It's 99.87% chance. So probability that somebody makes less than 56,000 is 99.87% or 0.9987. Probability that somebody makes less than 49,000 is 0.9772 or 97.72%. And this is how you find the probability for continuous random variable. In this case, the particular continuous random variable involves normal distribution. So this normal distribution is an arbitrary normal distribution. That means any mean, any standard deviation, that we translate it in, kind of map it into standard normal distribution, which has a mean of 0 and standard deviation of 1. Then we look it up into the z-scores table, okay, and then find the probabilities. And that's how it's calculated. Now, I could have bypassed all of it and give you a calculator and have you do the things and not understand anything, but I don't believe in that kind of teaching. I want you to do it by hand. I want you to understand it, why it's happening the way it's happening, and then you solve it. Like, I hear a lot of the times, not a lot, sometimes I should say, students say, oh yeah, I can add 2 fractions, 4/5 and 7/3 on the calculator, but I can do it by hand. So that means you don't know. That's what it means. You first need to know how to do the basics before you can use the calculator and come up with solutions faster. If you don't know the basics, you'll not, you shouldn't be using calculators. Okay. Then a calculator will be doing things for you, not you. Now, are these two things okay for everybody? I really want to make sure everybody is okay with it. Is there anybody who does not understand it? Please let me know at this point. Is everybody okay with it? These examples.
Kind of like in between, like I kind of get it, but I kind of don't at the same time. Maybe it's just because it's just over my head a bit right now. I don't know.
Okay.
It's a difficult process.
Okay. I think you just joined the class right now. You are late joining, aren't you?
Yeah, I joined at like 3 because I had like a dentist appointment. I just came back.
Okay.
And I had to. And
So
I can't join during 6 because I have another appointment with like a class or like a meeting, and I just couldn't. Sorry about that.
That's fine. But had you been in the class, from the beginning, you'd have seen the other 2 examples. You just joined in the middle. But I will be doing more examples. It should clarify things for you. Anybody else?
I mean, I'm fine. It's in the middle with me because if like, I think I'll be fine with it, honestly.
Okay. All right. Anybody else has any other question? Okay. If no questions, then I'm going to give you another example. I want you to do this one. Find the probability that someone makes more than $49,000. Okay. In this one, you did less than, compare it to this one, more than 49,000. For this one, I'll give you 2 minutes because Once you have done this, everything is the same structurally. And then you just need to go ahead and do it. Just think of it in terms of the area that you're looking for, then you should be okay. So take 2 minutes and then I'll do it. Anyone got this one? X greater than 49,000. Okay, George has something. Anyone else? Anybody struggling with this one? Okay, so let's see. Dennis, what do you got? Looks about right. So let's go ahead and work on the problem. Again, the same distribution. We are making it simple. 35K. 7K, right? Means 0 standard deviation of 1. 49 would be somewhere here, 49K. And we already know that 49 maps to a z-score of 2. So greater than 49,000. So I'm talking about the area to the right. Remember, in continuous random variable or continuous probability distribution, probability is found by considering the area under the density curve. This is called density curve or density function. So for this is the same area would be right here. Okay. So probability of X greater than 49,000 is gonna be probability of Z greater than 2 because Z is equal to 2. Probability of X greater than 49,000 is the same as the probability of Z greater than 2. Now, this is the area I'm looking for as well, okay? But if you look it up on the z-scores table, for z is equal to z is equal to 2, or probability of, let's write it slightly differently, z is equal to 2, the value you're gonna get is 0.9772. That, by the way, is the area to the left. That's the area to the left, not the area to the right. I don't want the area to the left. I want the area to the right. So this, when you're looking at z is equal to 2, you're in essence looking at probability of z less than 2, which is 0.9772. You're looking at the area to the left, okay? So how do I find the area to the right? Anybody? How do I find the area to the right?
Subtract it from 1.
Okay, who is talking?
Jessica?
Okay, Jessica. Why? You are right, by the way, Jessica, but could you explain yourself?
Well, if 0.9772 is everything from that point to the left, we still need that little portion on the right. So we have everything on the left. So if we just take the entirety of the graph, which is, 100% of it or 1, and subtract it, you will get that small little area that's left over.
Thank you, Jessica. That's exactly the explanation. All the area under the density curve, everything, okay? All the area under the bell-shaped curve must add up to 1 or 100%. If we know that the left side is 0.9772, then the right side should be 1 take away 0.9772, right? Which is 0.0228. So probability of Z greater than 2, which is this area, is in essence 1 minus the probability of Z less than 2. So pay attention to this. Okay, one is greater, another is less. When you subtract it from 1, it has to be less than. So 1 minus this value, by the way, is 0.9772, 0.9772, which is the same as 0.0228. That is the same as 2.28%. So the probability that someone, a randomly selected person, makes more than $49,000 is 2.28%. That's what it is. Is this clear, everyone?
Yes.
Any question, anybody?
That actually makes more sense now. I kind of understand it more. Thank you.
Okay. Anyone else? All right. Let's go ahead and do another example of same type. Find the probability that a randomly selected person makes more than $28,000. Quickly do it. Just 2 minutes again. So what do you got? Anybody? .1587. Okay. Anybody else got anything else? .8413. Okay, so let's just do it. Okay, right. So 28,000 would be somewhere here, right? 28K. More than 28K would be all the area to the right of 0.28. Everything here, right? So since this point is the middle, 0 is the middle, 35K corresponds to the mean of the standard normal distribution, which is 0, and 28K is left of 35K, so it's going to be left of 0, so Z. If you do the math, you'll find that Z is equal to -1, by the way. By now, you should know how to find the Z value, right? But I'd still do it quickly. So we are looking for this. This point corresponds to this point. Z is equal to X minus mu over sigma, which is 28,000 minus 35,000, all of it divided by 7,000. That is equal to -7,000 over 7,000. Which is -1. So that's what it is. Now that's the same as probability of Z greater than -1. Now, this time you don't look at the same table, okay? This time you don't look at the same table. You are looking at the positive Z-scores table. But if you just go right above on page number 5, you'll see negative Z-scores table. So that's where you look at. At the negative Z-scores table, you go to -1, okay? On page number 5, you go to -1, and you see that the value you get is 0.1587. So Z is equal to -1. That corresponds to a value of 0.1587. However, that gives you this area, because remember this standard normal distribution table, it gives you area to the left, not to the right. It gives you this area, but this is not what you want. You want the other one, right? You want the area to the right. So all you have to do is you need to subtract it from 1. 1 minus the probability of Z less than -1. Look again here, this is greater than, and when you subtract it from 1, it becomes less than. So which is 1 minus probability of Z less than -1. So probability of Z less than -1 is 0.1587. So it's going to be 0.1587. If you subtract, you get, so 1 minus 0.1587, that is going to be 0.8413. 0.8413, which is 84.13%. All right, that's what it is. 84.13%.
Oh, so okay, so I get it. So it's like you have to go in order of, because I did it. I accidentally like went in order at 3500 minus 2800 because like, oh, I'm just gonna do it so it's not a negative, but it doesn't matter. So it can be a negative. The Z.
Yeah, Z could be negative.
Okay.
Of course.
I was like, uh-oh, like what I did wrong, but that makes more sense.
So now, yes.
Thank you.
So this area to the right is the same as this area to the right. So they are equal, okay? But with respect to their own curves, of course, proportionately. So that's how you'll do it. Now, the next problem I'm going to give you is this one. This is slightly different. By now, I feel that you have the tools and the expertise to do this. So let me just draw a horizontal line here. And I want you to find the following: probability of somebody making between 28,000 and 42,000. Probability of somebody making between 28,000 and 42,000 here is telling you X is between 28,000 and 42,000. Exact same information, everything as before, but this time you are looking for the probability that a randomly selected person makes between 28,000 and 42,000. So this one, you may have to think just a little bit, but I want you to think first, then I will do it. So again, take a couple of minutes and work on it. Okay, guys, how do you feel about this problem?
I think I got it, but I think I might have not. Either way, I either did or either not.
You either got or you didn't.
Yeah,
right?
if you know what I
this
mean.
was-
Like it's like you just gotta go whatever you know, and then if you did
Yeah.
it, that's great. But if you didn't,
All right.
this
can I
one's a
see if-
little bit more confusing than the other one. Huh?
I think
Yes.
I think it speaks for itself. If I'm right, I could be wrong. If if I'm wrong, then I'll bite my tongue. Let's see.
Okay, so let's do it here. 35K, 42K, 28K. You want to find the probability that it falls between, the income falls between 28K and 42K. That means, oops. That means you are looking for the area in between 28 and 42. Okay. Now, next, we need to convert it into standard normal distribution, which is mean of 0 and standard deviation of 1, mean of 0 and standard deviation of 1. And as you already know, this number and this number, they convert or translates to -1 and +1 for z values. So in essence, you're looking for the area in between these two.
Yeah, that's what I did. I was like, I knew what 2800 was -1. And I knew what 1 was 1400. And I was like, I mean, it has to be whatever in the middle of those two. I mean, but I checked to see if it could, because it could have been like something stupid like a 0.5 or something. So I just went. Could it be a decimal or no? Or can it? I think it can, right?
Yeah, it has to be a decimal or
Yeah.
percentage between 0 and 100%.
Oh
so
no, I mean the z-score for the
z-score could be
2800X. It
any
could be a
real
0.5,
number.
right? Okay.
Z-score could be any number on the real line.
But
Okay.
I just did 0 because I was like, I think 0 is the right answer.
Okay. All right. So now let's go ahead and look at it. If we look it up in the z-scores table for 1.0, the value is point. So z is equal to 1. That gives you a value of 0.8413. And z is equal to -1 is equal to -1. That gives you a value of 0.1587. So probability of z less than 1 is 0.8413. Okay, from this I get that. And probability of z less than -1, not 1, is, by the way, 0.1587. Now let's come back to our graph. For z less than 1, so it's going to be all the area to the left of this one, including this unshaded region. Including the unshaded region, but I don't want the unshaded region. I want only the shaded region. So how do I get the shaded region? Now let's look at probability of z less than -1. Look at this number, -1. So this point. This, if you look it up on the table, is 0.1587 for z value. That is this unshaded region. So from the total area, if I take the unshaded region away from the total area from here all the way to the left, if I take this unshaded region away, I am left with this middle shaded region, which is exactly what I am looking for. So that is to say, probability of -1 is less than z is less than 1 is the same as probability of z less than 1 minus the probability of z less than -1. Probability of z less than 1, which is going to give you all the area to the left, minus the probability of z less than -1, which is all the area from here, unshaded region. That's going to give you the shaded region in the middle. So which is, so probability of z less than 1 is 0.8413 minus unshaded region is 0.1587. That's gonna give you 0.6826. Okay, which is 68.26%. Yeah, that is what it is. Is this clear to everybody? Now, the middle region is 68.26% or 0.6828. I mean 6826. This middle portion is also 0.6826. Is this clear to everyone?
Yes, it is actually really clear. Okay. That makes more sense.
Now, have you noticed something here? So there is a reason for me to give you this problem. Have you noticed that for this standard normal distribution, you moved one standard deviation to the right and one standard deviation to the left of the mean. Empirical rule tells you that should include roughly about 68% of the data. Remember, back in the days when I talked about empirical rule, I told you if you move one standard deviation to the right and one to the left, you include roughly about 68% of the total data. And then I said, oh, if you want to be a bit more precise, just say 68.2% of the data. But in reality, actually, it is 68.26% of the data. It is 68.26% of the data. So that's what it is. So that's the kind of like the proof of empirical rule. Now, next, I'm gonna do the same thing. Probability of 21,000 is less than X is less than 49,000. Now, if you do the math here, you'll see this is the same, it's 49,000. Probability of -2 is less than Z is less than +2. You'll see that. Probability of -2 is less than Z is less than 2. So instead of going one standard deviation, you're going two standard deviations in either direction. Remember, that said 95% of the total data. It said 95% of the total data. So now it's going to be probability of Z less than 2 minus the probability of Z less than -2. The probability of Z less than 2 minus the probability of Z less than -2. Now, if you look at probability of Z less than 2, by the way, that is going to be 0.9772, I believe, minus probability of Z less than -2, less than -2 is going to be, where am I here? 0.0228, 0.0228. And that is going to give you 0.9772 minus 0.0228, which is going to be 0.9544, which is 95.44%. Do you remember? We talked about two standard deviations. If you move two standard deviations away from the mean in either direction, then you include approximately 95% of the total data, which is actually 95.44% of the total data. Okay? And that's two standard deviation. Now, if you go three standard deviations, there will be like probability of 14,000 is less than X is less than 56,000, which is probability of -3 is less than Z is less than 3, which, by the way, is probability of Z less than 3 minus the probability of Z less than -3, which, if you look it up in the table, for +3, you get 0.9987, 0.9987 for this one. And for this one, you get -3 gives you 0.0013, 0.0013. If I do the subtraction, 0.9987, 0.9987 minus 0.0013, that gives me 99.7%, 74%, or 0.9974, which is the same as 99.74%. Remember, I said if you move three standard deviations away, it includes roughly about 99.7% of the data. So that is what the empirical rule is. We have talked about the empirical rule at the beginning of the semester I just didn't give you enough justification for it. I just said, oh, okay, just take these for granted. So here we are going to go ahead and show you how to find these things, okay? So basically, what you need to do, you need to apply this standard normal distribution table and find the corresponding probabilities, and then you'll get everything. Any question, anybody?
I think it says it for itself.
Okay,
Speaks for itself, my bad.
No.
anybody else, any comments? All right, now let me go ahead and do something slightly different. The same thing, let's do this example. Mu is equal to 35K and sigma is equal to 7K. And you want to find the, how much do you have to make, okay? How much one has to make to be among the bottom 5%. Bottom 5% of the income level, okay? As a policymaker or as a politician, you may want to know, I want to target those people who are making less, okay? I want to help them out. So how much one has to make in order to be among the bottom 5% of the income level, okay? So I'm asking you to do that. So go ahead and try to work on it. I'm gonna give you like, I really want you to try it 3 minutes because it is gonna be a little bit of a thinker, not too hard, but it's gonna be a little bit of a thinker. I want you to think. Before I do the problem, I'm gonna randomly select people and ask you questions, what you tried, and you need to explain. So make sure that you are working on it. All right, start working on it. Any question before I actually let you work on it? Okay, so go ahead and work on it. All right, guys, how did it go? Anybody got it? I see $23,485. So let's go ahead and find it. So this is 35K. And this is 7K standard deviation. So you want to be among the bottom 5%, bottom 5%. So it's gonna be somewhere here. So there's 5%, that shaded region. Associated with that, there is an X value. And we don't know what that X value is. Associated with it, there is an X value. And we want that X value, because if your income is less than or equal to X, that means less than or equal to this number, you'll be among the bottom 5%. All right. So now we don't know that. So what we can do is we go to our standard normal distribution. Okay. That has a mean of 0 and standard deviation of 1. And again, we look at the left 5% or 0.05. This area is 0.05. the shaded region, this region. Associated with that 0.05, there is a Z value. And that Z value, by the way, is going to map to this X value. That Z value is going to map to the X value. Now, how do I find that Z value? Now you go to the Z-scores table. Everybody go to the Z-scores table. And this area is 0.05, which is less than half or 0.5, right? So you're going to be looking at negative Z-score. If your area is less than half, you're looking at the negative Z-score. If your area is more than half or more than 0.5, you're looking at positive Z-score. So 0.05 is less than 0.5 or half. You're going to be looking at the negative Z-score, and we look at it, and it is going to be, you look this time, by the way, you do not look on the Z column. What do? You have the Z, and these are the values 0, 0, 0, 1, and all the way 0, 8, and 0, 9, right? You look actually inside the table. You look inside the table and find the value that is closest to 0.05, closest to 0.05. And if you look at the table, they have 0.0505, and then
is it
0.0495. Okay.
is it the one is it negative 1.6, or is it 1.6 or 1.7?
Okay, so if you look at this, there is an arrow with a star mark in between. This arrow goes to, by the way, a value that is negative 1.645. This goes to the value negative 1.645. So that means your Z is negative 1.645, negative 1.645 for an area of 0.05. So now we know we can go back and forth between Z and between standard normal distribution and any normal distribution using the Z-score. So my Z is equal to X minus mu over sigma. The distinction between this problem and the ones that we have done so far is that in the last ones, we are looking for Z, but here we are actually given Z. So this is going to be negative 1.645. We already have it. X is the value we are looking for. We don't know. So X minus mu is $35,000 divided by sigma is 7,000. Now to solve for X, what we are going to do, we are going to multiply both sides by 7,000. Okay. So now this is going to cancel. That's going to give you X minus 35,000. And on the left, 7,000 times negative 1.654, 645 times 7,000. That is going to be negative 11,515. Negative 11,515. Now to solve for X, I add 35,000 to both sides, 35,000 to both sides. If I do that, on the right, I get X because these two cancel out. And on the left, I get 35,000. So it's going to be 23,485. $23,485. So your X, by the way, is $23,485. So if you make $23,485 or less, you'll be among the bottom 5% of the wage earners. You'll be among the bottom 5% of the wage earners. If you're making $23,485 485 or less, or roughly about, if you make 23,500 or less, then you're among the bottom 5% of the income level. And that's how you find it out. Now, another very natural thing you could do is this. Okay, how about if I want to find out who are among the top 5%? So in that case, you'll just do this top 5%, 0.05. Again, here you'll find the corresponding thing, 0.05. And by symmetry, you can see, by symmetry, what I mean, remember I told you bell-shaped curves are symmetric about the middle, right? About the center. So left half is a mirror image of the right half. So if this left is 0.05, this right is 0.05, and if this point is negative 1.645, then this point is going to be z is equal to positive 1.645. So you could do the exact same thing, but instead of using negative, you're going to do 1.645 is equal to x minus 35,000 divided by 7,000. Then if you do the math exactly the way I did it here, multiply both sides by 7,000, right? $7,000, then you're gonna get 11,515 is equal to x minus 35,000. If you add 35,000 to both sides, you're gonna get on the right, these two cancel out, that gives you x. On the left, it's gonna be 46,515. So if you make, so this x is gonna be, x is $46,515. So if you make $46,515 or more, or roughly 46,500 or more, then you fall among the top 5% of the wage earners, or top 5% of the income level. So that's, you're considered rich, and somebody else considered poor, who makes less than 23,500 versus 46,500. And that's how you do these problems. Today's lecture, I covered a lot about normal distribution and how to play around with different kind of probabilities. So you should be pretty good with it. This is very important, how to go back and forth between any normal distribution and standard normal distribution, because that's going to help you guys find probabilities by finding the area. Any question, anybody? Everybody okay?
Yeah, I think I'm
How did
fine
you get
actually.
Yeah.
645?
Makes sense.
Yeah.
Everybody okay?
How did you get 1.645?
Is by symmetry. Remember, bell-shaped curve is mirror image about the middle or the center, so about this line. Left is a mirror image of the right. So this left area here, this shaded region is 0.05, and this shaded region is 0.05. For this shaded region of 0.05, you got negative 1.645. So for the right side, you'll get positive 1.645. Or you could look it up from the table too. Is it okay?
I understand how one side is the same as the other, but I don't see the math for 1.645.
You know how I got negative 1.645, right?
No, that's the part I don't get.
Oh, you have to look it up in the table. See, on the table, if you look at negative z-scores, you will find the closest value inside the table that is closest to 0.05 are these two values. So they take an average of it and puts the middle here. And if you look at the star, it has a star on it. You'll see that arrow goes back to this value. if you look at up in the table. Did you look at the table?
Yes.
So if you
Yes.
look at the, do you see it now?
Yes.
What?
Sorry.
Okay, so that's where I get this value from this one. But by symmetry, meaning that one is a mirror image of the other, I get this value. But there is another way of finding the next, finding this value. I'll show it to you next time. Okay.
Okay. Thank you.
Mhm. Any question? Anybody else? All right. We'll stop here for the day. Thank you very much.